Section 2 of Food Values by Dr. Albert Phillips Sy. This LibriVox recording is in the public domain. Prices. The commercial value of foods is intimately related to diets and nutrition. Frequently, a change or a fad in diets causes a change in price. But much more frequently, the reverse is true. A change in prices produces radical changes in diets. When potatoes were $1.20 a peck, people ate less of them, and the steady rise in meat prices is gradually lessening meat consumption. The present price of flour and bread is turning people's attention towards corn products. It will not be necessary to discuss the reasons for high prices. Nearly everybody has a theory about them. The writer believes that high prices in this country are due principally to the increasing amount of gold and use of credits. Of course, just now the war is an important factor, but prices were steadily rising even before the war. Chemical composition and fuel value. To many people, the value of a food depends upon its chemical composition. A food with a high percentage of fats, carbohydrates, or proteins, or all of these, is a rich or valuable food. But it is evident from what has been said that more than composition must be considered. The composition of food is, however, important, and a diet in order to be adequate should supply from 3,000 to 3,500 calories a day to a man doing ordinary work. One of the simplest and at the same time safest rules is to provide a mixed diet which will give from 3,000 to 3,500 calories daily. The proteins, vitamins, and food essentials will take care of themselves if proper emphasis has been put on mixed diet. Explanation of terms used. Calorie. This term is used as the unit of heat measurement. It is the name given to that amount of heat which will raise the temperature of 1 kilogram, 1,000 grams, of water 1 degree centigrade. A calorie will raise the temperature of nearly 4 pounds, 3.968, of water 1 degree Fahrenheit. When a combustible substance is burned, a certain definite amount of heat or energy is liberated. As the chemist and the physicist say, the reaction is exothermic. The heat liberated is called heat of combustion, and its amount, measured in calories, is called the calorific value of the substance. Fuel value, calorific value. These terms are used with reference to the amount of heat produced when a substance is burned. Food value. In a chemical sense, food is burned in the body, and the effect or energy produced is often called food value. The fuel value of a food is the theoretical amount of heat that may be produced. But since foods are not completely burned in the body, the heat or energy liberated is less than called for by theory. The correct expression for the energy produced in the body is the physiological fuel value. Rich or concentrated food, one that has a high fuel value. Amino acid. An organic acid which contains one or more NH2 groups. It contains nitrogen combined with hydrogen. Most of the other organic acids do not contain nitrogen. A complete protein is one in which has in its chemical makeup the amino acid or acids necessary for the formation of new protein. Complete food. One which contains at least appreciable amounts of proteins, carbohydrates, fats, minerals, and growth essentials. Such a food is always physiologically complete if a sufficient number of calories are provided. Relish. Something eaten for its flavor without reference to food value. Relishes seldom have an appreciable food value and are eaten alone or mixed with other foods. Explanation of the charts. The best method of showing the composition of foods and of dietary values is by means of colored charts. By far the most elaborate and accurate charts of the kind are those prepared by Professor C.F. Langworthy of the United States Department of Agriculture and published by the department. The percentages of composition used are based largely upon data given in Bulletin 28 of the Department of Agriculture, the The Composition of American Food Materials, compiled by Atwater and Woods. By permission of the Department of Agriculture, the Langworthy charts have been used as a basis for the following reproductions. Besides the reduction in size, the following changes should be noted. In the originals, water is represented by a green color, while in the following charts, the part intended to show the proportion of water has been left uncolored. The ash is shown by fine dots, stipple, instead of a dark gray in the originals. Representative examples of different classes of foods are shown, first as to composition and second as to food values. The composition is indicated by percentage figures of proteins, carbohydrates, fat, water, and ash or mineral matter. These percentages are given to the first decimal place only, and represent averages of a great many analyses of the edible portions of American food material. In these charts, the composition is visualized by using different colors for different components. The amounts of colors are approximately in the proportion indicated by the percentages. The color key appears at the top of each chart. Proteins are shown in red. The percentages shown are obtained by determining the percentage of nitrogen by chemical analysis and multiplying this by 6.25, giving the percentage of protein. Fats are shown in yellow. The term fat in food analysis usually refers to the substances that can be extracted by means of ether and are sometimes called crude fat. Natural fats are always mixtures of a number of compounds, each of which is chemically classed as a fat. Chemically, a fat is nearly always a compound formed by the union of glycerin and a fatty acid. Foods, therefore, contain not only different amounts, but also different kinds of fats. Carbohydrates are shown by a blue color. In the edible portions of foods, carbohydrates consist principally of starches and sugars, but in analytical data, the term carbohydrates includes also cellulose, gums, and woody fiber. The cellulose and woody fiber are usually present only in small amounts and are not digestible. They are also known by the term crude fiber. Some analysts define carbohydrates as nitrogen-free extract plus crude fiber. Ash, also called mineral matter, is shown in the finely dotted part and consists mainly of salts, chlorides, phosphates, sulfates, of potassium, sodium, calcium, magnesium, and a few other elements. Analytically, the amount of ash is determined by burning away the combustible part of a food and weighing the incombustible residue. The portion of the pictures intended to represent the water in the foods is left uncolored. In the analysis of food, water is determined by heating in a drying oven at a temperature somewhat above 100 degrees Celsius to constant weight. The loss is calculated as water. In addition to the chemical composition, the charts below show the food value of each food by a black rectangle and a statement in figures. The black square in the key represents 1,000 large calories. The black rectangle under each food gives an approximate idea of the number of calories per pound. In the charts, the term fuel value is used. This is the term usually used to express food value, although the two are not synonymous. A food is looked upon as a fuel, a body fuel, and if a food is nearly all digested, the term fuel value is sufficiently accurate. It should be noted that the components of a food are mentioned under 5 headings: proteins, fats, carbohydrates, ash, and water. It must not be inferred that foods contain nothing else. Many foods contain small amounts of substances that are chemically and physiologically different from any of the above mentioned 5 classes. Included under the term proteins in meat, there are certain water-soluble substances simpler in composition than proteins and known as extractives. Associated with some fats, there are non-fatty substances without which the fats are physiologically or nutritionally incomplete. Without these, growth is incomplete. They are sometimes called growth determinants. In this bulletin, the term growth essentials is used. A most important factor in a physiologically satisfactory food is its flavor and odor. However, the substances producing these qualities are present in very minute quantities, and do not appear in the percentages. Vitamins, also present in many foods, and without which a diet would be incomplete, are not shown in food charts or tables of composition. Their chemical nature is as yet only partially known, and methods for their quantitative determination have not been discovered. It is fairly certain, however, that the percentage is quite small. End of section 2.